So,
Yes.
so today in the tutorial, entire portion of application of matrix will come.
Yeah. That
Okay, okay.
two-dimension
I mean
application.
only the last part or the full portion.
Last part, two-dimensional applications. I
Acha,
mean,
transformation.
yeah, transformations
Okay,
and
okay, okay.
yeah.
Thank you, sir.
Yes.
And sir, will there be any part of derivatives?
Yeah. I mean, beginning of a derivative.
Okay, sir.
Don't worry, it will be very easy, as like previous tutorials. All right. Is my screen visible?
Yes, sir.
Okay.
Yes, sir.
So let us quickly recall what we did last time. We have started with successive differentiation, that is any nth derivative, uh, and our target is to get a general formula for nth derivative of some function. Okay.
Sir,
Yes.
sir, your voice is very less, sir.
Uh, what about others?
No,
It's
sir,
okay,
it's
sir.
fine.
Yeah,
Sir,
I
it's
think
sufficient.
problem is at your end because I'm using.
Okay, sir, I am checking, sir.
Yeah, yeah. Please check.
Sir, you may
All right.
continue, sir. I am checking.
Okay. So our target is to get general formula for nth derivative of some standard functions and to apply it to get nth derivative of some function which is not here. Okay. So out of which we consider first example, that is y is equal to e raised to ax. Its nth derivative we observed that it is a raised to n e raised to ax. Okay, and we are denoting it by y suffix n. Then second example or second function we considered was a raised to x, whose nth derivative is a raised to x into log a raised to n. Okay, into log a raised to n. And then third function was y is equal to ax plus b raised to m, where m is any real number. Okay, and we observed that its nth derivative is m into m minus 1 into m minus 2 and so on, m minus n plus 1 into a raised to n ax plus b raised to m minus n. Okay. Uh, then I told you to make some cases on m that we'll look at today. Fine. So this is subcase of third. Okay, this fourth number is subcase of third. So y is equal to ax plus b raised to minus m. Okay, and m is positive integer. And m is positive integer. So the particular example of this kind is 1 upon 2x plus 3 raised to 5. Okay, 1 upon 2x plus 3 raised to 5. How will you write it? 2x plus 3 raised to minus 5. Is the function clear? How it will look like?
Yes, sir.
Yes, sir. Yes, sir.
Yeah, good. So where m is positive integer, keep in mind. So y1, its first derivative is minus m into ax plus b raised to minus m minus 1 into derivative of ax plus b, that is a. Okay, then take its second derivative. So minus m and a will be treated as a constant, So minus m, a as it is, derivative of ax plus b raised to minus m minus 1, that is minus m minus 1 into ax plus b raised to minus m minus 2 into a. So that will become a square. Okay. Now what I will do, I'll take minus sign out of this bracket. So this minus sign and this minus sign will become minus 1 square into m plus 1 into a square ax plus b raised to minus m minus 2. Okay. So on similar line, it will be y3. So this minus m minus 2 will come here. I'll take minus sign out of it. So that will become minus 1 cube. So m into m plus 1 into m plus 2 a cube ax plus b raised to minus m minus 3. All right. So what will be yn? This is n, minus 1 raised to n. By mistake, that ma'am has wrote 3. This is minus 1 raised to n. Please make a point of it. This is minus 1 cube, minus 1 raised to n. So m into m plus 1, m plus 2, and so on, m plus n minus 1. You can observe whenever there is 3 here, this is m plus 2. Okay. So there is n. So this number will be 1 less than that. So m plus n minus 1 into a raised to n ax plus b raised to minus m minus n. Okay. So here is the general formula. Any doubt?
No, sir.
Okay. What about others?
Sir, why we do minus 1, sir? N minus 1. We have to consider only n now.
In which step you are talking about?
Sir, y raised to n. General equation, sir. Why we considered n minus 1?
This m plus n minus 1.
Yes, sir.
Okay. Observe the pattern from first. Forget about y1. y2. If you consider y2, then this is m plus 1, right? So one number less than this. In y3, this is m plus 2. So one number less than 3.
Got it, sir. Got it.
Yeah. So for n, it will be n minus 1.
Sir, please scroll down a little bit.
Fine.
Yes, sir. Thank you.
Yeah. So this minus m minus n, you can take a denominator. So that will become x plus b raised to m plus n.
Sir,
Yes.
sir, in the practice questions that you have given,
Hmm.
sir, can I send you the picture of the solution? Because in the solution, the coordinates of A and C has been interchanged.
Uh,
Because I've solved it 2-3 times, I'm getting the same answer.
Yes, sir. I
uh,
also got the similar thing.
about which question you are talking about? I mean,
The transformation of matrix, the second last question of
all right.
application of matrices.
All right. All right. You can send it to me. I'll see. There can be mistakes in answers.
Thank you, sir.
Yeah. Okay. Have you copied this? nth derivative of the function like 1 upon ax plus b raised to m. By the way, how do you write this in terms of factorial if you want to write it? Anybody?
Sir, m factorial upon n minus 1 factorial.
M factorial.
No, sir, I'm factorial upon
N plus 1 factorial.
no.
M plus 1 factorial. No.
So 1 minute.
Anybody else? I want to write this m plus 1, m plus 2 up to m plus n minus 1 business in terms of factorial. What adjustment I should do? See, for time being, you take m as 5. Okay. So what is happening? 5, 6, 7, and so on. Okay.
So we can multiply and divide by n plus n.
M plus 1. Why m plus 1?
Sir, m plus n, m plus n.
M plus n.
So then the upper part will be n plus 1 factorial upon.
How do you bring 1, 2, 3 in picture?
Then we'll have to multiply. Okay, got it, sir.
Yeah. Okay. Good. Okay. I once again repeat. You take some m particularly. So let us take m is equal to 5. So 5.
Sir, we can also do m plus n minus 1 factorial upon m minus 1 factorial.
Yeah, that's what I want.
Yeah, sir.
Okay, multiply and divide by m minus 1 factorial. Okay?
Yes, sir.
Yeah. And then you can write numerator as m plus n minus 1 factorial upon m minus 1 factorial into ax plus b raised to m plus n. Okay? So if you understood, you can write it. Otherwise, you can keep as it is. All right? I repeat, you can multiply by 1, 2, 3, 4 up to m minus 1 to numerator, and you can divide by the same number 1, 2, 3 up to m minus 1. So that number is m minus 1 factorial. So this whole numerator will be m plus n minus 1 factorial upon m minus 1 factorial. Okay, and all other terms are there. Minus 1 raised to n is there, a raised to n is there, ax plus b raised to m plus n is there. All right. So secondly, if y is equal to ax plus b and m is positive integer, that means if you consider particularly, so 2x plus 3 raised to 5, 2x plus 3 raised to 5, and m is greater than n. Okay, I'll explain why this condition is there. If my function is 2x plus 3 raised to 5 and I am finding its 7th derivative, what it will be? Anybody?
What did you say the function was?
2x plus 3 raised to 5. Okay, my m is 5 and n is 7. I am finding its 7th derivative.
So it will be 0.
Yeah, good. Do you understand?
Yes,
Everybody?
sir, 0.
Okay. So,
Sir, please explain once more.
yeah.
Sir, this will be a case where n is greater than m, na? Not m is greater than n. Excuse me, sir?
Yeah. You are correct. I am explaining why we wrote this. why we wrote this
Okay.
m greater than n.
Okay.
So somebody said to explain, if you have x raised to 5, let us take uh, x cube. Okay, what is its first derivative? 3x square, right? Right?
Yes, sir.
Yes, sir.
What is its second derivative?
6x.
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 What about third derivative?
6.
6.
6.
And what about fourth derivative?
0.
0. Okay, so my m was 3 and uh, n is 4. Okay, so for every number 4, 5, 6, that derivative will come as 0. So this case is true for m greater than n. Okay, if order of derivative is greater than its degree, then in that case derivative will be always 0. Is that clear to everyone?
Yes, sir.
So can you
Yes,
repeat
sir.
once again?
If order of derivative, that means this n, is greater than degree of this polynomial, then derivative will be 0.
Okay, sir. Yes.
Okay, so let us derive a general formula for this. Okay, please understand the difference. Here it was 1 upon ax plus b raised to m, and here it is ax plus b raised to m. Okay, and m is greater than n. This degree of this polynomial is greater than order of derivative. Then we are deriving this. So what will be its nth derivative? We have already derived this formula, m into m minus 1 into m minus 2 into m minus n plus 1 into a raised to n, ax plus b raised to m minus n. We derived this, okay, last time. Here it is. For any m, it is m into m minus 1, m minus 2, and so on, m minus n plus 1, a raised to n, ax plus b raised to m minus n. Okay. So now I want to write this thing in terms of factorial. So I should multiply and divide by some factor. And what is that factor?
M
So to
minus
understand,
N.
yeah, to understand it, you can consider some particular m. Okay. So suppose m is 5, then it is 5, 4, 3, 2, 1. Okay. So divide and multiply by m minus n factorial, isn't it? Do you understand? You will have to multiply and divide by m minus n factorial.
No, sir. No, I'm not able to understand.
Okay. So take m is equal to 5 and n is equal to 3. Okay, everybody, those who don't understand this, please take m is equal to 5 and n is equal to 3. All right. So m is equal to 5. So 5 minus 3, that is
2,
2
sir.
plus 1. So this number is 3.
3. Okay.
Okay. And you are starting with 5. So 5, 4 and 3. Okay. This is your coefficient. Okay. 5, 4
Yes,
and
sir.
3. So what is missing there? 1 and 2 is missing there.
No, sir, but it is part of the formula, so it is not missing, no?
No. Where it is? It is not part of formula.
No, sir, but this is not any special case. This is the normal case where n is less than m. So we can normally derive it also. No, differentiate it also.
See, I'm explaining why we are adding this m minus n, m minus n minus 1 up to so on 3, 2, 1.
Yes, sir.
Okay. So if you are talking about general thing, I'll explain in general. That is also fine. So m, m minus 1, m minus 2 and so on, m minus n plus 1. This is already there. Okay. Now what is next number to it? What
M
we are
minus
doing?
n.
M minus n, because we are subtracting 1 from each bracket. Okay.
Okay,
So
sir.
then m minus n plus 1 minus 1, that will become m minus n. What is next number?
M minus n minus 1.
M minus n minus 1. And where will it stop?
1.
At 1. So we have multiplied by this factor, m minus n, m minus n minus 1 and so on up to 1. So we need to divide it. Okay. Because we are
Okay,
doing
sir.
adjustment. So we have divided it by m minus n, m minus n minus 1 and so on up to 1. So how do you write this numerator now? This numerator you have 1, 2, 3 up to m. Okay, 1, 2, 3 up to m. So what is this number?
That is, sir, m minus, no, wait, m minus n minus 1 factorial upon m minus 1 factorial.
No, 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 no. See, again observe it. 1, 2, 3, 4 up to m. What is that number?
M factorial.
M factorial only, no?
Yeah.
And what is denominator?
M minus n factorial.
M minus n factorial.
N factorial. Okay, so that's what the general formula is.
So you're saying that n is equal to m.
No.
So, sir, in the numerator, why would it go from m to 1?
See, m is greater than n, no?
Huh?
So this number will be always positive. Whatever numbers you are taking will be always positive, isn't it?
Okay.
So first nth derivative is m, m minus 1, m minus 2 up to m minus n plus 1. Okay.
Huh.
I want to write this term in terms of factorial. So what I am doing, the numbers which is less in that, I am multiplying and dividing by that number. Okay.
Okay.
And this is that factor m minus n, m minus n minus 1 up to 3, 2, 1 is that number which will give me m factorial in numerator.
Okay.
Okay, so I have multiplied and divided by that number. So we have m factorial a raised to n ax plus b raised to m minus n upon m minus n factorial. Okay.
Yes.
Yeah. Okay.
1 minute, sir. 1 minute, sir. Yes.
Yeah. So just to understand it, I write down one problem. Y is equal to minus 2x plus 3 y is equal to minus 2x plus 3 bracket raised to 44
Okay.
bracket raised to 44 double 4 minus 2x plus 3 bracket raised to 44. Okay. And question is find its 41st derivative. 41st derivative. Okay. What is m here?
44.
44.
And 44 and 41.
n is
41.
41. Okay.
41 we have to find it, yes, sir.
Yeah. So find out y 41. 41th derivative. So it will be m factorial, that is 44 factorial a raised to n. What is a in our case?
2.
Minus 2 raised to
Plus
41.
Minus 2 raised to 41. Good. Into bracket minus 2x plus 3 raised to 44 minus 41.
2.
3.
3.
3.
Sir, 3.
Yeah.
3.
Upon
3 factorial.
3
3
factorial.
factorial.
Yeah. Understood how to apply it? And then you can simplify that number.
Sir, what will happen if we take a minus common out and then we write the equation as 2x minus 3 whole power 44?
Then you will have to take minus 1 raised to that power common, because minus 2 will come again and again, no?
Sir, but in what terms you have to leave the equation?
You can leave as it is or you can simplify if you want. It is up to you.
Okay, sir.
Is the doubt clear about minus 1 the power?
Yes.
Yes, sir.
Okay. Fine. So I hope you have copied this formula for ax plus b raised to m, where m is positive, m is greater than n. What about m is equal to n? What about m is equal to n? What will be nth derivative? So my question is, your function is y is equal to 2x plus 3 raised to 5. Okay, 2x plus 3 raised to 5. And you are finding its fifth derivative.
So 32 into 5 factorial.
Yeah, 32 into 5 factorial. That is 2 raised to 5 into 5 factorial. Okay. So in general, it is a raised to n into n factorial. So write down this sub case. If y is equal to ax plus b raised to m is positive integer. If y is equal to ax plus b raised to m and m is positive integer and m is equal to n. That means degree of that polynomial is equal to,
Sir, m equal to and then the derivative will be constant, right?
that
Constant
will be,
number.
that will be constant number, right? Here it is n factorial into a raised to n. How do you get it? You just substitute m is equal to n in above formula. So that will become n factorial a raised to n ax plus b raised to n minus n. So that is ax plus b raised to 0 upon n minus n factorial. So 0 factorial is 1. So this is n factorial a raised to n. Okay? Copied? Please respond. Copied?
Yes, sir. Yes, sir.
Yes, sir.
Yes.
Then
1 minute, sir. 1 minute.
last, yeah, okay.
Done, sir.
Yeah, okay. So let us consider this last step. When degree is less than order of derivative. As I explained, if your polynomial is x raised to 5 and you are finding its sixth derivative, okay, where m is 5 and order of derivative is 6, then it will always come as 0, isn't it?
Yes, sir.
Okay, so MCQs can be asked based on this particular cases. Okay, so keep in mind.
Sir, by what time will you send the PDF? You have not sent it till now.
Oh yeah, I'm sorry about it. I forgot it yesterday. I'll send it after lecture.
Okay, sir. No problem.
Okay, so now if y is equal to x raised to n, okay, what is its nth derivative? Look at this case. M is equal to n. What is its nth derivative? Nth derivative of x raised to n?
n factorial.
N factorial, because a is 1. Coefficient of x is 1. So 1 raised to n will be 1. But what about n minus 1 factorial, n minus 1 derivative of this? Will it be n minus 1 factorial?
N minus 1 factorial into x.
N minus 1 factorial
Into x.
into x.
Sir, you're asking for x raised per n, no?
Yeah, x raised to n.
गलत तो नहीं है.
N factorial into x. And how do you get this? From this. Okay.
Sir, what was the question?
If x raised to y is x raised to n, what is its n minus 1 derivative? Okay. Do you believe that it is not n minus 1 factorial?
Yes, sir.
Okay.
Yes, sir.
In particular, if we have polynomial x raised to 5, so its fourth derivative is not 4 factorial. That's what I mean by this. Fourth derivative is not 4 factorial. Now what it is, we are in this case. Okay. X raised to n, that means degree of that polynomial is n, and we are finding its n minus 1 derivative. Okay. So m is n and n is n minus 1. So tell me, what What will be n
5
minus?
factorial times x.
Yeah, 5 factorial times x. So what it will be in general? If it is x raised to n,
N factorial x.
n
And
factorial
factorial
x.
x.
Yeah, good. And from this we are getting it. Okay. So if y is equal to x raised to n, then n minus 1 derivative is n factorial times x. Okay. Please note it down. Done? Yes or no?
Yes, sir.
Sir, just a minute, just a minute.
Yes, sir.
Can we go ahead?
Yes, sir.
Okay. So let us find particular case of y is equal to ax plus b raised to minus m. Okay. So where m is 1. Okay. So let us go back to that case. Tell me, if y is 1 upon ax plus b, what is its nth derivative? Will you please simplify and tell me? M is 1. Yes, anybody?
So for n greater than 1, it will be 0.
How come?
So you said the function is y is equal to ax plus b only, right?
No, no, no. I'm talking about this 1 upon ax plus b.
Oh, sorry. Okay.
Sir, can you repeat the case?
Y is equal to 1 upon ax plus b. Then what is its nth derivative ka formula? Okay, I'll explain. So m is equal to 1. So 1 into 2.
Sir, minus 1 raised to n into n factorial into a ki power n upon ax plus b ki whole power n plus 1.
Yeah, good. Very good. Everybody understood? See, m is equal to 1. So 1 into 2 into 3 and so on up to this 1 plus n minus 1. So this 1 and minus 1 will get cancelled. You will have n. So 1 into 2 into 3 up to n. That will become n factorial. So minus 1 raised to n into n factorial into a raised to n upon ax plus b raised to n plus 1. Okay, m is 1.
Yes, sir.
Right. So that's what mentioned here. So y is equal to 1 upon ax plus b. Then yn is minus 1 raised to n into n factorial a raised to n ax plus b raised to n plus 1. All right. Now, when will this 1 upon ax plus b be useful? That is the question. Okay. Now, if I ask you, what is nth derivative of 1 upon x square plus 3x plus 2? 1 upon x square plus 3x plus 2.
Sir, we'll do partial fractions and then
Yes.
use this formula.
Okay, very good. So in that case, you will do partial fraction of the denominator. So you will write that 1 upon x square plus 3x plus 2 as a upon factor of that quadratic polynomial plus b upon second factor of that polynomial. And then you find out those coefficients a and b, capital A and B I'm talking about. Okay. And once you have those coefficients, you can apply this formula to get nth derivative. Is the point clear to everyone?
Sir, can you just repeat once more, sir, please?
I repeat, if you have polynomial like 1 upon x square plus 3x plus 2, what are the factors of x square plus 3x plus 2?
X plus 1 into x plus 2.
X plus 1 into x plus 2. Okay. So what is its partial fraction? Just find out those coefficients immediately.
X plus 2 minus x plus 1.
Why minus?
Sir, what you asked last line, can you repeat again, sir?
Do partial fraction of 1 upon x square plus 3x plus 2. I hope everybody knows partial fraction.
Finally, it will be 1 upon x plus 1 whole minus 1 upon x plus 2.
1 upon x plus 1 minus 1 upon x plus 2. Is it? Yes? Is it?
Yes, sir, because numerator could be written as x plus 2 minus x plus 1.
Yes, sir.
Okay. So what you have is 1 upon x plus 1 minus 1 upon x plus 2. So now you can apply nth derivative ka formula, okay? So minus 1 raised to n factorial a raised to, or a is 1 in that case. So x plus 1 raised to n minus n plus 1 minus minus 1 raised to n into n factorial 1 raised to n is 1 again. Denominator x plus 2 raised to n plus 1. Okay. So we are going to see those problems later. I just want to make a point that we are going to use this fact to find out nth derivative of 1 upon quadratic or cubic polynomial where we use partial fraction. Okay. Is the point clear to everyone? Let us see how to solve those problems later. Okay. Please respond.
Okay, sir.
Okay, sir.
Yes, sir. Okay, sir.
Now this fifth point, if function is log of ax plus b and we want nth derivative of this function. Okay. Can you tell me? What is its first derivative? 1 upon ax plus b into a. Okay. Now we want nth derivative of this function. That means you differentiate y1 how many times?
N minus one.
N minus 1 times. So a is constant, you can take it out. What is n minus 1 derivative of 1 upon ax plus b?
Minus 1 raised to n minus 1 into n minus 1.
Yeah.
N minus
A की power
n minus 1
n minus 1 upon
ax plus b into n minus 1 plus 1.
not into, raised to. Okay,
Yes, raised to.
raised to n minus 1 plus 1. Okay, I repeat. See, y1 is a upon ax plus b. So we are going to take n minus 1 derivative of this y1. So a is constant, you can take it out. So you can see that a is here. What is n minus 1 derivative of 1 upon ax plus b? So here it is yn. Okay, 1 upon ax plus b, and here it is nth derivative. We want its n minus 1 derivative. So wherever there is n, you replace it by n minus 1. So this is minus 1 raised to n minus 1 into n minus 1 factorial a raised to n minus 1 upon ax plus b raised to n minus 1 plus 1. Okay, now this is a raised to n minus 1 into a, so that will become a raised to n, and minus 1 raised to n minus 1 into n minus 1 factorial upon ax plus b raised to n. Okay, so just note it down. Any doubt here? Okay, what about others?
No, sir.
No, sir.
No, sir.
No, sir.
No, sir. No, sir.
No, sir.
Copied? Can you go ahead?
Yes, sir.
Sir.
Okay. So up till now, we were in the case y is equal to ax plus b raised to m. Okay, and then we made some cases on m. M is positive integer, m is negative integer, m is minus 1, likewise. Okay, so let us just look at this function and then we'll stop. Y is equal to sine bx plus c. Okay, and what is its nth derivative? That is the question. So what is first derivative? Cos of bx plus c into b. Okay, now how do you write this cos in terms of sine? I'll simply add pi by 2, isn't it? So this cos can be written as in sine. So b into sine of bx plus c plus pi by 2. Right? You got the first point?
Yes, sir.
Okay. Now you differentiate it. So what will be y2? cos of bx plus c plus pi by 2 into b. So that will become b square. Okay. So again, you write this cos in terms of sine. So b square as it is, sine of bx plus c plus pi by 2, and add one more pi by 2. So that will become 2 pi by 2 upon 2, or 2 pi by 2. What will be y3? Can you tell me?
B cube into sine of bx plus c plus 3 pi by 2.
3 pi by 2. Okay. So in general, what is its nth derivative? B raised to n sine of bx plus c plus n pi by 2. Okay. Please note it down. If you have any doubt, you can ask. Okay. So in case of cosine, if y is equal to cos of bx plus c, if y is equal to cos of bx plus c, what is its nth derivative? B raised to n cos of bx plus c plus n pi by 2. Okay, please understand that whenever there is sine, in nth derivative there is sine. Okay, so for cos it is cos. So y is equal to cos of bx plus c, then yn is b raised to n cos of bx plus c plus n pi by 2.
Sir,
Yes.
sir, won't the minus will come as cos x derivative is minus sin x? So
Yeah, but we are adjusting it in pi by 2, no? Look at that quadrant.
yes. Okay.
Yes. Please note down these two formulae. Finished?
Yes, sir.
Okay, just last point because it is there in a tutorial. If my function is y is equal to sine 2x into cos 3x, and question is find its nth derivative. Sine 2x into cos 3x. What will you do? Because up till now we don't know how to take nth derivative of product. Okay, you know general formula for sine 2x separately. You know general formula for cos 3x separately. But there is a product, sine 2x into cos 3x. How
Sir,
do you do
we
that?
can use the formula sin c cos d is equal to sin c plus d by 2 into cos c minus d by 2
Okay,
into 2.
so please understand this because this problem is there in tutorial, today's tutorial. Product
Sir,
of
can you
sine and
repeat?
sine 2x into cos 3x. This is product of sine and cosine. So to find nth derivative, you will adjust 2. Okay. So divide and multiply by 2. So what is 2 sine A cos B? 2 sin A cos B.
Cos A plus B by 2 into sin A minus B by 2.
Is by 2 there divided by 2?
Yes, sir.
Are you sure?
Sir, it's sin A plus B plus sin A minus B. Right?
Sin?
A plus B plus sin A minus B.
Yeah. Good. Okay. So, do you understand how you are going to deal with that problem?
Yes,
Divide
sir.
and multiply by 2. For product of sine and cosine, divide and multiply by 2 and use the identity 2 sin A cos B. Okay? Understood?
Yes, sir.
Okay. Everybody, so that we will stop here.
Yes, sir.
Yes, sir.
Okay, okay. So, may I stop sharing the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, have you posted your name and roll number in chat box?
Yes, sir.
Yes, sir.
Everybody.
Yes, sir.
All right. So, we'll stop here. You can leave this meeting. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.